Hi, this is Tammy. I do Math for Coffee. The other day I was helping someone with a problem like this, and I decided I better show everybody how to do one of these because they are very intimidating. Do you know how to do it? All right, let's start with a couple things. When we teach negative exponents, we use this rule. A to the negative m equals 1 over a to the m. And then we just start moving into problems, or at least that's how I used to teach it. And I think what I should have done is made it more explicit and just said, okay, if you have a to the negative m over 1, that's going to turn out to be 1 over a to the m. And then they could see what's happening a little bit easier if you have a fraction compared to another fraction. And so for a problem like this, you have to recognize that this is also true. If you have 1 over a number raised to a negative exponent that's in the denominator, it's going to flip up to the numerator and become positive. The first thing I want to do is take care of this negative 1 exponent that's being applied to this entire group. So that negative 1 needs to be put on everything that's in that group. I recopied the first term just as it is, and then now I end up with 2 to the negative 1. Y to the third power raised to the negative 1 power would be y to the negative 3, and negative 2 times negative 1 would be z to the positive 2. If you need a review of exponents, I'll put a link up here in the corner about why I'm multiplying them instead of adding them. All right, now I'm just going to recopy the denominator. Let's try to simplify this a little bit. I know that this 2 and this 2 are going to cancel. I'm seeing something I want to play with here. I have y to the third power multiplied by all the things that come after it, and one of those things is y to the negative 3. Well, when you're multiplying two things that have the same base, you add their exponents. So we're going to end up with y to the 0 power, and that it just equals the number 1. So that in effect, these two just cancel each other out. They're not just gone, they just turn into a 1, so they aren't going to change the product at all. Rewriting a little bit, I now have everything on the top that's left is 2 to the negative 1, and then I have a z showing up in a couple places, but it has two different exponents. We are going to add those exponents. A negative 3 plus a positive 2 is going to leave me a negative 1. On the bottom, the 2 canceled, and I still have x to the negative 2, y squared, and z to the negative 1. Before I do anything else, look, z to the negative 1 and z to the negative 1, yeah, you can do some more work with that, but you could realize that if you have the exact same thing on top and bottom, they cancel each other out too. What are we left with? We have 2 to the negative 1 on top, x to the negative 2, y squared on the bottom. Now I'm going to go back and use these rules and move things around. Negative exponents flip to the other side. A negative exponent on the numerator will go to the denominator and vice versa. Okay, so what's going to end up on the top is this x squared. And on the bottom, you have 2 to the first power, which is just 2, and then y squared on the bottom, that squared was positive, so it's just staying right here. And this is our answer. Did you get that? If you have any questions on a problem like this, go ahead and leave them down below. I'll be happy to help you out. Thank you for watching. I'll see you guys next time. Bye.